Καλησπέρα σε όλους. Συνεχίζοντας το session του Cyber Security and Cryptography, θα ήθελα να καλωσορίσω τον κύριο Βαγγέλη Γαζή. Όπως ήδη γνωρίζετε, η ομιλία του κύριου Γαζή θα πραγματοποιηθεί στα αγγλικά. Οπότε και εγώ με τη σειρά μου θα συνεχίσω την παρουσίαση σε αυτά. So, continuing with the session of Cyber Security and Cryptography, I would like to warmly welcome Mr. Gazis. Mr. Vaggelos Gazis is the Chief Architect for IoT Security in Huawei, and he will be presenting us his talk titled as Developments in Standards and Policy for IoT, a Global Perspective. At this point, I would like to remind everyone that you can submit your questions throughout the talk's duration so that Mr. Gazis may answer them at the end of his talk. So, Mr. Gazis, whenever you're ready, we may begin.
Thank you, Mr. Papafotiou, and thank you once again for the kind invitation to your event. Good morning, good afternoon, and good evening, everyone, from wherever you may be watching this session. I will be spending the next 25 to 30 minutes giving you an overview of IoT security policies and standards as they have been developing in the last 2 or 3 years on a global scale. But before we start, maybe I should give you a first introduction of what we mean by IoT. Well, if you look at the definitions in ITU or other standards bodies, any device which interfaces with an actuator or a sensor and can definitely communicate with other systems is considered an IoT device. So the communication capacity is an essential attribute of an IoT device. Sensing attributes and actuating attributes are optional. So that gives us an idea of the kind of devices we're talking about. And maybe now we can have a look at a worldwide map, I would say, where we can see the different activities being undertaken regarding those devices. So there are multiple activities globally regarding IoT in the UK, the European Union, Finland, the US, but also Australia, Singapore, and Japan, and I will be walking you through those. What's important to note is that although there are different activities taking place, these are not done in isolation. So there is a stream of global alignment between the standardization bodies and the policy stakeholders. For example, in July 2019, Australia, Canada, New Zealand, the United States, and the United Kingdom set out a commitment to align their approaches on enhancing the security of IoT devices. And as we go through the different nations and the approaches that they have chosen, you would see the similarities. I would like to start with a bit of overview of the activities that have taken place in the European Union. Those activities concluded in the so-called EN 303-645. That's just some, alphabets and numbers. But what that is a European standard for cybersecurity for consumer IoT, and specifically the baseline requirements for consumer IoT. Now, when I say European standard, I need to clarify that it is not just a technical specification which has been developed by a standard body and which is voluntary. It is at the moment voluntary, but it also carries the approval of all the member states. So this standard has the approval of all the national authorities and which have taken part in the review process. The motivation behind the N30645 was in response to widely known cybersecurity incidents. I'm sure some of you are aware of the widely publicized impact of the Mirai botnet, which resulted in a 1 Tbps DDoS attack against DIN, knocking the provider offline. But there are also of other activities that have been spinned off basically from the Mirai botnet. For instance, the Satori botnet numbered approximately 800,000 devices. And there have been also other botnets like Okiru, OMG, and Wicked, which are all Mirai, largely Mirai variants, and which continue to be active in one form or another. So in response to that recognition of the large-scale threat that can emerge through IoT, there was the initiative behind the N303-645, whose purpose is to improve upon a non-existing provision for cybersecurity and data protection in IoT. For better or worse, largely until now, the devices that you would find in IoT would not have sufficient cybersecurity and data protection measures implemented into them. And while that may not hold true for the well-known large-scale manufacturers, because there are a large number of smaller manufacturers that take place and are active in IoT, that is something that would say characterizes those manufacturers. So, and that is basically one of the issues that had led to the emergence of those botnets that we mentioned. To address these shortcomings, EN 30645 tries to improve the situation from a zero baseline to a common baseline. And it tries to apply that baseline across the European and the wider global market. And that's where the consensus of the 27 member states counts. It is an outcome-focused specification. So it does not define technical tests, but it defines what the outcomes of those tests are or should be. And it includes 33 requirements, 33, as we call them, shall provisions, and 35 recommendations, so 35 should provisions. Having said that, let's look at what those provisions look like and what they refer to. So as you see from the upper left corner, there's a provision number 4, which refers to reporting implementation, which is actually one of the novelties of 303645. For every provision in 303645, which is listed as a recommendation, and which the manufacturer does not implement, the manufacturer is required to provide a reporting implementation where he or she includes the reasons for not implementing that provision. This is a specific measure taken by the standard in order to improve transparency, because it enables whoever wants to inspect the declaration of conformance of an IoT device to look into the reasons that are claimed by the manufacturer and to judge for themselves on whether those reasons are well justified, make sense, or even at the end suitable for their own use cases. Other provisions in 303645 include the system telemetry data, the ability to examine them, to make it easy for users to delete user data so that devices that are repurposed or exchanged among users and customers do not lead to exposure and leakage of personal data. To make installation and maintenance of devices easy, I remind you it refers to consumer devices largely. To validate input data, a large source of the vulnerabilities is attributed to poor input data validation, as we know, but also to make systems resilient to outages, to refer from using universal default passwords, and to keep software update, and to securely store sensitive security parameters like credentials, private keys, and so on and so forth. There's also a provision which imposes on manufacturers to implement a means to manage reports of vulnerabilities so that then the manufacturer can be more transparently held in a way accountable for what they do with those reports of vulnerabilities. There are also data provisions for data protection for consumer IoT to ensure that personal data is secure, to ensure the software integrity, but also as very important provisions to minimize the exposed attack surfaces, to communicate securely. And those are also supported by 2 annexes. Annex A provides the basic concepts and models that have been applied by the standard body in developing this standard. And Annex B provides, as we call it, an implementation conformance statement. It's a statement where the implementer declares and checks the provisions against which they made the product compliant to. So let's look a bit on the implementer's view of EN 30645. If you or I were tomorrow to try to implement a standard, what would we have to do? We would look at the definitions in the Annex A to understand what the standard body had in mind. We would review those terms. We would have to implement all 33 requirements, and we would be expected to make the best efforts to implement the 35 recommendations. And for those that we don't, we would be required to provide a rationale for those choices. There's also a companion standard, which is TR 10362, which will be published and will provide guidance for the implementers in doing all those activities. And following the implementation, the next step for an implementer is to prepare the conformance statement, to complete the Annex B, and then to prepare for an assessment. Now, the assessment can be in-house, meaning the manufacturer themselves assess the product and provide the report, or they can be by an external body. However, the assessment should be based on TS 103701, which is the companion standard and which provides the test specification for EN 303645. So we have basically, as you can see, a triplet of standards that work together, and they provide the requirements, recommendations, and mandatory requirements, the test specification, and the guidance for applying 303645 on consumer IoT devices. This is the situation right now in the European Union. And having said that, I would like to jump across the Atlantic to the US to give you an update on what activities the National Institute of Standards and Technology has undertaken. So there's a cybersecurity for IoT program that is being executed at NIST. And the purpose is to provide guidance on defining IoT cybersecurity requirements. You will see that here there are also multiple standards that apply, and they work in companion to each other. There's a special publication from NIST, the 800-213, which provides guidance for the federal government for IoT device cybersecurity on how to establish device cybersecurity requirements. And that's an essential part in order to be able for federal government stakeholders to apply the other 5 standards that come from NIST. Those are on the 8259 series from A to D. And the basic component for those is the 8259, which defines the foundational activities for cybersecurity that IoT device manufacturers should undertake. It covers the scope of activities relevant for IoT device manufacturers. The 8259A defines in more clear terms the core baseline of cybersecurity capability, meaning the cybersecurity capacities and features that an IoT device should have. Because at the end of the day, when you're looking to the whole system, there will be a level of reliance upon the individual features and capabilities that each IoT device will have. And therefore, there has to be a baseline for those. So 8259 addresses that. It's a technical specification, and the companion to that is a 8259B, which is a non-technical supporting capability core baseline. That refers to the manufacturer. It defines the abilities that the manufacturer as an organization should make available when they take IoT devices to the market. For instance, to be able to receive reports about cybersecurity events, vulnerabilities, to be able to share information about cybersecurity to their customers, but also to the community, and so on and so forth. Another document is the 8259C, which is guidance on creating a profile using the previous 2 documents. So it's basically how does one take 8259A and 8259B and then use the information about the organization, the use case, and the environment in order to create a custom profile of how to apply those 2 standards. And finally, 8259D is a specific profile which has already been developed, which refers to the federal government in the US. So it's a profile that guides the federal government stakeholders in applying 8259A and 8259B in their own use cases and applications and scenarios. So all these standards work together. It's a pattern that we see across the world. I will just likely to summarize it here. So the main guidance is provided by 8259. 8259A to D are the specific parts for manufacturers, the first two, and the other parts are a guidance for organizations and specifically for the federal government. If I wanted to show you a visual on how these work together, now that would be it. There is, as we say, a foundation, which it comes from the special publication 800-213, which defines the guidance on IoT device cybersecurity for the federal government. And upon that, we have, of course, the specific 8259D profile for the federal government, which has already been built. But however, any additional profile can be built in a customer-centric way by following the guidance from 8259C and applying select parts of the 8259A and the 8259B. So this is the process and that you can use to define, and not just you, any organization can use to define a specific application profile for NIST IR 8259 for their use cases. There are also legislative activities that are taking place at the federal level in the US. So recently we had the Internet of Things Cybersecurity Improvement Act, which mandates NIST to develop standards and guidelines for the federal government on the use and management of Internet of Things devices by agencies. And those standards and guidelines will refer to security vulnerabilities, how to get reporting for them, how to handle them, how to manage the vulnerabilities reported, what will be the process, how to support secure development for IoT software devices and applications, how to conduct identity management in terms of establishing the process, providing governance, and executing identity management in operations, how to do patching and to prioritize patching, and finally, how to actually do configuration management in a cybersecurely proper way. In addition, there are standards and guidelines under this act for device manufacturers. So there is the guidelines there for coordinated vulnerability disclosure and the resolution of vulnerabilities by the manufacturers. And there's also information sharing guidance and guidelines about those vulnerabilities, about sharing those vulnerabilities with other stakeholders in the community. Those guidelines are in alignment to international standards and specifically ISO 29147 regarding vulnerability disclosure and ISO 30111 regarding the vulnerability handling process. Going beyond the federal level, looking at the state level, in the US, we have had the Cybersecurity of Connected Devices Act, which has been legislated in the state of California. And they define requirements for a manufacturer of a connected device. So they are required to equip the device with reasonable security features appropriate to the nature and function of the device. This implies a risk assessment, but also appropriate to the information it may collect, contain, or transmit. So this also implies a data risk assessment. Now, there are also specific requirements as alternative, which are set by the legislation. For instance, regarding to having a pre-programmed password, which is unique to each device manufactured, and the device containing a security feature that requires the user to generate a new means of authentication before access is granted to the device for the first time. So these are specific things that are set in legislation for the state of California. And of course, they apply in addition to whatever applies federally. Now, in the US, there are also industry activities for cybersecurity certification of IoT devices. The CTIA defines 3 levels of increasing device complexity, sophistication, and manageability. And applies per combination of hardware, software, and firmware release version, where there is a change relevant to security. So if we are just merely changing the color of a UI, no change there for the certification. Level 1 refers and covers terms of service, privacy policy, password management, access control, user authentication, patch management, and software upgrade. So this is the minimum, the first level. Level 2 on top of level 1 includes audit log, data in transit confidentiality, multi-factor authentication, secure boot, remote deactivation, and threat monitoring. And level 3, the highest, includes also data address confidentiality, digital signature generation and validation, tamper evidence, and design features in support of cybersecurity, for instance, design for secure failure and so on. So this is the picture at the US. And jumping now across the Pacific into Singapore, we will look at the Cybersecurity Agency of Singapore, which has defined a cybersecurity labeling scheme for consumer smart devices. Now that level defines 4 tiers of increasing testing and assessment, and it's a voluntary scheme. The label is under this scheme is valid for as long as security updates are available, but up to a maximum of 3 years. The tier 1 and tier 2 refer to the manufacturer, and they cover baseline requirements and lifecycle requirements. Lifecycle requirements includes things such as the software development practices and so on and so forth. Tier 3 and Tier 4 refer to a third-party independent laboratory testing, and they include requirements for software binary analysis and penetration testing. So again, here we have a level of increasing or additive tiers, as we call them, in terms of the assurances that they offer. However, we have 4 instead of 3. Going on to Japan, we have there the introduction of the IoT Security Safety Framework, which is relatively earlier as a body of work, still at an early stage. Now, this framework follows 2 perspectives. There's a perspective of risk analysis from the degree of economic impact of incidents. And there's also a perspective of degree of difficulty of recovering from the incident, and devices as well as systems are covered. Now, this twofold risk analysis allows us to identify security safety requirements. So there's a perspective of security and safety. And that's a fairly logical thing to do, considering also that IoT devices will find themselves in cyber physical systems, and therefore they will be use cases that involve safety requirements. And the other dimension is the degree, as I mentioned, of difficulty of recovery from the incident and the degree of the economic impact of the incident. So this 3-axis cube gives us then different layers upon which requirements can be imposed incrementally. So there's requirements that concern before the operation of the device, for instance, which have to do with the manufacturer, the provider, operation, when the market and when the IoT product is taken to the market. So these are also operational requirements, but there are also requirements 1 level up for the operator, like licenses and so on, as well as other requirements for mechanisms that cover also social support. And this is relevant in this context because I remind you that there are also safety requirements in place. So there's a social dimension to this framework of policies and standards that will be developed. Moving on a bit southern and going to the Australia, the Australian Government Department of Home Affairs has published a code of practice for securing the Internet of Things for consumers. Now, that is a code of practice which is voluntary to apply for manufacturer, and it is based on 13 principles. Now, if those principles seem somewhat familiar, it's because they are aligned to the work that has been done in the Europe and also in the UK. And they are derived as part of the International Alignment Program, which I mentioned in the start of the presentation. So those principles cover default or weak passwords, vulnerability disclosure policies, the secure update of software, the storage in a secure way of credentials, protection of personal data, and so on and so forth. It's a common sense set of principles, basically, that have been refined actually through and validated, refined and validated in multiple countries. Now, coming back to the UK, the Department of Digital, Culture, Media and Sport, or DCMS for short, had a consultation on regulation to secure consumer IoT. And that is about taking specific requirements for consumer IoT devices and putting them into legal requirements. And the candidates are the top 3 guidelines within EN 30645 and TS 103645. Just to mention, TS 103645 is just a technical specification which mirrors and follows EN 30645. It is there only for reasons of procedure, and the content is identical. Now, the top 3 guidelines are about passwords. So IoT device passwords must be unique and not resettable to any universal factory setting. Also to vulnerability disclosure policy, requiring manufacturers of IoT products to provide a public point of contact as part of a vulnerability disclosure policy. And last but not least, security updates. So manufacturers must explicitly state the minimum length of time for which the device will receive security updates. According to data from incidents, those top 3 requirements by themselves attribute for roughly 85% of the IoT security incidents that we have been witnessing over the last years. So the idea of the CMS here is that by putting those 3 top requirements into law, 85% of the security incidents attributed to IoT will be mitigated. Finally, in another country in the European Union, in Finland, the Finnish Transport and Communication Agency has introduced a cybersecurity label. Again, that is aligned to the work under EN 30645. It adopts the same requirements. There are specific fees per application or annually for refreshment of the label. And it provides a description of the products and what measures there are to protect against common threats in IoT. Not surprisingly, these refer to passwords, privacy protection, network services, in particular interfaces that are available for ecosystem partners, but also secure defaults and the security of data in transit and data at rest. And coming back again and looking at the big picture one more time, I think we can say it is clear that over the last 3 years, nations have undertaken policy initiatives in the cybersecurity of IoT. Several regions of the world have taken significant efforts to actually provide uniform standards in their domain, in their authority, in their jurisdiction. While there are some differences among the schemes, for example, in terms of the levels or in terms of the tiers, we can see that there is convergence which is emerging among initiatives and schemes, and most of the schemes address the same pain points. There are particular secure by design principles that an IoT manufacturer should apply in IoT device development, and manufacturers will be more and more expected to apply those principles. In addition, there has been an established baseline for cybersecurity capabilities that an IoT device should avail, as we have seen from the activities in the European Union, but also on the US side. And last but not least, the responsibilities of the IoT manufacturer with regard to vulnerabilities have been highlighted as an item of top priority and possibly one that will be legislated. So all these are the different aspects, and these are I would say, the top areas of concern for policy, standardization, but as recently we have seen, legislation stakeholders across the world today in the area of IoT cybersecurity. And with that, I would like to conclude the presentation and hopefully give the floor to any questions you may have. Thank you.
Thank you very much, Mr. Gazis, for your interesting talk. So I think we can begin with the audience's questions. First question. The European Union holds a strict policy for technology-based companies regarding cybersecurity. How should European Union legislation be changed in order to remain up to date with the ongoing international situation?
There are activities already which are happening to remain up to date with the international situation. Several of those activities are being pursued, and they have been also upgraded through the Cybersecurity Act. So there are activities to coordinate the sharing of information about cybersecurity incidents on the one hand between member states and their respective authorities. There are activities to improve and upgrade the cybersecurity capacities across member states. And there are also activities which are being taken at the European Commission level and the European Parliament level, which have to do with legislation. For instance, the directives and the regulation. So as we know, there's an ongoing activity that is proposing to address some of the concerns about cybersecurity in delegated acts of the Radio Equipment Directive. This is under discussion at the moment. We have seen that there is a proposal from the European Union also for a study on the common cybersecurity requirements for ICT products that could lead to another legislation. So as we see, there are activities at least 2 or 3 levels: legislation, standardization, but also industry associations. And there are channels between those activities to remain aligned to what is happening globally.
Great, thank you. Second question. For an European Union context, how has the GDPR affected IoT design guidelines? How must personal data collection via IoT devices and any subsequent handling, use, storage, etc., be done in order to be compliant and to be respectful towards the users from the privacy and autonomy perspective? I can also send the question in the chat.
Yeah, that's a great question. So there are, first of all, provisions in EN 3645 which have been put there in order to support some of the rights that are given by GDPR. For instance, the ability to easily delete all user data. However, most of the requirements for GDPR apply to the provider of the service, not necessarily to the IoT device, and only to the extent that an IoT device comes with a service pre-built into it, do they cover that device. So most of the devices apply to the IoT application provider, which from the GDPR standpoint is, as they call it, usually a data controller.
Mm-hmm. Nice. One more question. Is there a movement to unify the different IoT security standards across most countries / institutions?
I wouldn't call it a movement, but I would certainly say that people are aware of the need to converge to what they're defining in terms of requirements. So as you have seen, there is the commitment of 5 nations to do international alignment, and we have seen how that shows in the kind of policies and standards that they put into place. But for instance, one example I can give you is that the Cybersecurity Agency of Singapore, for instance, has established a channel of communication with the European Telecommunication Standardization Institute, ETSI, and the Cybersecurity Committee, exactly to get into alignment with EN 30645. So there's steps being taken both proactively, but also as part of international cooperation.
Right. Also, there is one final. Do popular IoT devices follow the standards you mentioned in your talk? And how can we ensure the devices we buy adhere to them?
Okay, that's a good question. So hopefully some of the information in the presentation will help you do that. So first thing an IoT consumer would do is to check, first of all, the conformance statement of the device. See the manufacturer, what is the declaration of standard implemented. And we can expect that EN 30645 will find itself there. I'm not saying it is now because the standard was finalized in 2020, so that will take some time for manufacturers to pick up on that. There will be also potentially a cybersecurity label applied to a device, and what the consumer can then do is look at that label. Who is the authority for that label? For instance, if it comes from the Finland, as we said, the Finnish authority, then the consumer understands, based on the information I shared, that it's aligned to EN 303645 and therefore aligned to a common baseline across the European Union. So at the end of the day, the consumer has to check what they're buying, because if you buy something blindly, well, of course, nobody can be held accountable for buying the wrong thing but yourself, right? So the consumer has to check what they're buying. The standards and the policies, what they do is they put the requirements in place for transparency so that the consumer has that information available. But at the end of the day, the consumer has to make the choice.
Wow, very interesting. So I think this wraps it up. Again, I would like to thank you, Mr. Gazis, for your amazing talk and your time.
Thank you so much for your kind invitation, and I hope I have kept the audience at least somewhat interested. I look forward to hearing the other speeches of the speakers. Thank you.
Yes, thank you. Λοιπόν, επιστρέφω στα ελληνικά. Στη συνέχεια θα περάσουμε στο lunch break και επιστρέφουμε σε 1 ώρα με το session Signal Processing.